Hello everyone, let's look at Leetcode question 680, Valid Palindrome II. At time of recording, this question has 8,000 upvotes and 413 downvotes. The question is, given a string s, return true if the s can be palindromic after deleting at most one character from it. Example 1, you see string s is ABA. This is a palindrome already, so we don't need to remove anything. How about this? ABCA, this is a palindrome if we remove C. Okay, we'll go into depth in these examples. The constraint is that the string s input length is between 1 and 100,000 characters. String s consists of lower English letters. Okay, running through the code, we can see first that we have a isPalindrome method. This method just checks if the string s is a palindrome. So we initialize by having the left and right characters, and the left and right characters starting at the beginning of the string and the end of the string, and we check each character if they're not equal. If they're not equal, then it's not a palindrome, so we return false. But if they are equal, we increment left by 1 and subtract 1 by right. And then we check once more if they are characters that are equal or not. And then finally we exit the while loop when left is no longer less than right. This means we have iterated through every single character, so we can return true. It is a palindrome in that case. And then this code right here is about indicating if we can delete at most one character from it if necessary. So we do the same thing. We define left and right to be 0 and length string -1, the beginning index of the string and the end index of the string. We do a while loop to iterate through every character while left is less than right. And we check if the string value at left index is equal or not equal to string index at right. Then we can check then if we can delete at most one character, which is exactly what this line is checking for. So we return is palindrome left right -1 or is palindrome left +1 right. So what this function is doing is checking essentially if the remaining characters are palindromic, and we return true if it is or false if it isn't. So in this case we say that okay, left is either not equal to right, so how about we check if left is equal to right -1, or we can check if left +1 is equal to right. This way we can satisfy the condition of deleting at most one character. Okay, and then we do the same thing as in the isPalindrome method, and we increment left by 1 and subtract 1 by right. Okay, and we only do this once. Note that this return method will return false and exit the entire code. However, if it is true or false, it will return anything, but if there is no need to compare the two, it will just continue as if it were a regular palindromic code, okay? And then we can return true finally if it's a palindrome without deleting a character in this case. Okay, in this first example then we have s equals ABCA, and we start then at here, this line of code, left and right. We define left and right to be 0 and length of string -1, so 3, index 3. And while 0 is less than 3, this is true, we check if string value left is not equal to string value right. A is actually equal to A, so we don't worry about this right now, and we skip this if conditional and say, okay, left increment by 1, B, right decrement by 1, C. Okay, so it's now B is C. And the index values are still left is less than right, and we check then string value left. Is that not equal to string value right? Is B not equal to C? This is actually true, so we then go to the next line of code in the if condition and check is palindrome left right -1 the same, or is palindrome left +1 right the same? Okay, so let's do the first one, left and right -1. This makes it so it's simply B and B index, okay? So it's 1 and 1. Okay, so we then go up to this method and we say, okay, left is less than right. Is 1 less than 1? Actually, 1 is not less than 1. 1 is equal to 1. So in this case, we actually don't need to do this if condition and just simply return true because it's the same value. B is equal to B. How about this? Is palindrome left +1 right? So it's an OR condition, so we only need 1. So we'll just run through this anyway to check. Left +1 is C, and right is C. So these are both at index 2. So we go to the palindrome and check while 2 is less than 2, 2 is equal to 2, so we simply return true. Okay, we only need one character to be true here, but both are true in this case, so we return true. And this is true, we could delete C in this case. Okay, let's check this next example. Input S would be race car, but there's a G between C and A, so it rates cigar. And then we check then. Okay, so this is the is palindrome method. We start then here, left, right, 0, and looks like 0, 1, 2, 3, 4, 5, 6, 7, index 7. While 0 is less than 7, we check if the string 0 is not equal to string 7. R is equal to R, so in this case, R is equal to R, so we don't do this if condition because it is equal, and we simply increment left by 1 and right minus 1. And we go back to the top of the loop. 1 index is less than 6 index, so we continue and we check, okay, string left is not equal to string right, A is equal to A. Okay, so we still don't worry about it not being a palindrome. So then we once more point A to C and A to G now. So while left is less than right, yes, the index left is less than right. If string left, C, is not equal to string right, G, okay, then we check return is palindrome left, right minus 1. Okay, so we do the palindrome with the remaining characters, subtracting 1 from G, so it becomes C. Okay, so then we go up to this definition method and we check left, right. Currently index is 0, 1, 2, 3, 4. The first C is at 2 and the second C is at index 4. So you can see we're checking for palindrome the remaining characters after the G. And let's check. Left is less than right? Yes. String left is not equal to right? No, they are equal. C is equal to C. So we can increment E, and right minus 1 is also E. So we arrive at the middle value now, and we check, okay, is 3 less than or equal to 3? No, they're both at the same index, 3. Therefore, we don't return false, and we don't iterate again at the while loop, and simply return true. So return is palindrome true. And this makes sense because the only character that was making it so this palindrome could not be true is the G. And with this minus 1, we removed the G and we considered every other character then, and we saw that it is a palindrome after deleting at most one character. Okay, and since this was true, we don't care about if the next OR value is palindrome because it was the first one that would determine if it is true. So yes, this is true. Okay, let's check the solution. And it works. Great. So what is the time complexity? The time complexity of this solution is O of n, where n is the length of the input string. This is because we iterate through the string once to check if it's a palindrome, and in the worst case, we iterate through every single character in the string, yielding O of n. Time complexity. The space complexity is O of 1 because we use a constant amount of extra space to store the left and right pointers. That's it for this problem. Thank you for watching.